Ladies and gentlemen, we see on this warm-up that we have tick marks, which means these sides are what? The same or congruent. I know we don't have two headphones in our ears, right? Thank you. Keep it that way. So, if those sides are congruent, that means we can label the same side length, right? So, if that's 5, this one's 5. Now, we know Pythagorean Theorem, right? We know a squared plus b squared equals c squared. So, the one thing I've suggested is label a, b, and c. Okay, and a and b are next to 90, right? Here's my 90. So a and b are my 5 and 5. C is my x. Now, a squared plus b squared equals c squared would be 5 squared plus 5 squared equals x squared. Does everyone agree with that so far? Now, what's 5 squared? 5 times 5? Okay, so this is really 25 plus 25, which is 50. Good. Now, 50 equals x squared. How do I get rid of a square? The what? Square root. Opposite of square is square root. Okay? So we're going to put the square root sign on both sides. So, square root sign on the 50, square root sign on the x squared. Cancels that out. Now, square root of 50, remember, we are going to break it down with the factor tree. So it's even. 2 times what? 25, and then 25 is 2 doesn't work, 3 doesn't work, but 5 times 5, that works. I got a pair of 5, I got a loner 2. How do I write that answer? 5 on the outside. Square root sign 2. So this x over here, 5 squared of 2. Now, not too bad, but I want us to notice something, because today we're going to be talking about, like the objective said, that you wrote down so you don't lose points. We're doing 45, 45, 90. I want you to notice something. Well, first of all, let's figure out the angles, okay? We need to figure out z and y. Now, if this is a 90-degree angle, and we have two equal sides, what do we know about the opposite angles? They're also congruent. That was the Isosceles Theorem. Theorem. Now, what would those two angles have to be to add up to 180 for the whole triangle? So you're thinking 90 plus some number, that's the same, equals 180, and it is 45. So z, this has to be 45 degrees. Y, this has to be 45 degrees. 45, 45, 90 adds up to 180. So I want to tell you this. Every single time, is everyone listening? Every single time there's a right triangle with isosceles sides, you're going to for sure have two 45-degree angles. Okay? Now, here's the deal. What changed from this leg to this hypotenuse? What's the only difference? Square root of 2. Okay? So, guess what? If I change this one side to 3, everything else would work out the same way, and then I would have a 3 square root of 2. So has everyone seen the relationship? Whatever this number is on a 45-degree, 45, 45, 90, this hypotenuse will just add a square root of 2 next to it. And that's a rule that we're going to talk about today in our notes. Okay? So is everyone good on the warm-up? That's going to feed into our notes we're about to do right now. So let me pass that out. You can, if you missed a warm-up, you can just put that you were in the front office. Okay? So here we go. Notes on special right triangles. No. All right. So 45, 45, 90 triangle can be formed from a square. Okay? So check it out. You can write in the word square. If you have a square and you cut it in half diagonally, that'll give you 45, 45, 90. Okay? And it is also called a blank, blank triangle, an isosceles right triangle. So write those in, fill in those blanks. Good job. Oh, nothing. Oh, okay. True. So, if you have a square cut in half, that's an isosceles right triangle, and that makes 45, 45, 90. Here's why. If that 90 degrees cut in half, then that's going to be 45. That'll be 45. That'll be 90. Cool. Now, what did we learn from the warm-up? So, I know if you're writing, 1 second. What's the only thing that added to this 5 to get the hypotenuse here? Square root of 2. So, our rule is, if you have a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as each leg. Okay? Right? Now, when we're doing this, I like to use a little grid, because think of this as a puzzle, a fun puzzle. Okay? I should put it on an app, and it'd be super fun, right? But it is kind of like a puzzle. We have a grid, we fill in what we know, we figure out what we don't know, voila. Okay? It may have been a while since you've done standardized testing for math. Okay? Back in the day, it was the TAKS test, right? Back in my day, it was the TOS test. TOS. And then now it's the EOC or STAR or whatever. But you would have this formula chart. Boom. You would have this formula chart, 45, 45, 90 is x squared root of 2. It's kind of the idea that we learned from the warm-up. So here's what I want you to write. Whenever you have this grid, the left side is for the angles. So spoiler alert, tomorrow we're going to learn a different set of rules. But for today, it's 45, 45, 90. In the middle, you're going to put the rule. And then you're going to put in the values on the right. This is where we're going to do our figuring it out. So the rule we just set down here is x squared root of 2. And the way this grid is right here, I'm going to give you that whenever we do this stuff. So like, if we have a problem like this in the test, you'll either have a formula chart or it'll be on your test where you can use this grid. The thing you have to know is how do I fill it in? How do I solve for the missing side? So, let's do that. Let's first draw this little diagram. So it looks like a 45, 45, 90. Whatever this is the same as this. And the hypotenuse just adds a square root of 2 on the end. Okay? So, without further ado, let's do some examples. Okay? Now, we already did on our warm-up an example with Pythagorean Theorem. Now, on the notes, they want us to check every one of them with Pythagorean Theorem, but because we need to catch up on some stuff, I'm going to cut to the chase on the rules, okay? So, thank you. So, all right, number 1. This is the easiest example, okay? We're going to skip number 2, as you can see, but, okay? On number 1, this is going to be the easiest example. I want us to write our little grid that we just talked about, okay? So, first of all, what kind of triangle is it? I see 90, I see 45, so what would the other one have to be? 45 for it to add up to 180, which means 2 equal angles, 2 equal sides. So, let's write our little grid. 45, 45, 90. And my rules for 45, 45, 90 is x square root of 2. Here's where you have to think a little bit. The only number they gave me was 8 for a side. What is 8 across from? So if you want to draw the arrow, that's cool, but 8 is across from what angle? 45, not 90. So I'm not going to put it down here. I'm going to put it up here. Very good. And remember, if you know one of the legs, since it's isosceles, right? Basically, and this right here, x equals 8, so that means this x also equals 8. Now, if x equals 8, this last blank, I'm going to replace that x with the number 8. So x squared root of 2 is going to equal what? 8 squared root of 2. If you know the leg of a 45, 45, 90 triangle, it's not that hard. You just, both legs are the same, add a square root of 2 onto it. That's it. Is that doable? Most of your assignment, I think, is those types. So pretty easy, kind of, right? Now we're going to skip number 2. And let's go flip to number 3 on the back, okay? 3 and 4 are going to be a little trickier. Okay, so please focus so you know what you're doing. Okay, what kind of triangle is this? Now I see I have x and x, so that's isosceles. So if that's isosceles, what are these two angles down here? They have to be congruent, and they have to be 45. Right? Okay, so now I know it's a 45, 45, 90. So let's fill in this. Let's make our grid first. 45, 45, 90. And my rule is x, x, x square root of 2. Now, remember, you don't want to be tricked. You want to be untrickable. What is 5 across from? It's across from 90, okay? So where am I going to put 5 in my grid? On the bottom, okay? So it's not always the easiest type of problem. Sometimes it's like this. So if you're given the hypotenuse, the longest side, and it's a whole number, we have a little problem here. Is everyone looking up at the board? Right? X square root of 2 equals 5. But I don't know what x is. X is not 5. X square root of 2 is 5. But guess what? This gives me a little equation that I can solve for x. Okay? So can we solve for x? Ideally, yes, we can. So here's what we're going to do. We're going to take this little equation, and we're going to rewrite it and solve. So x squared of 2 equals 5. If I want to solve for x, how do I get rid of that square root of 2? So those are being multiplied. What's the opposite of multiplying? Divide. So to get rid of that square root of 2 next to it, I'm going to divide on both sides. That cancels out, and now I have x equals 5 over square root of 2. So I have x equals. Cool. But do y'all remember what I said about having a square root on the bottom? We can't have a square root on the bottom. That was in our notes from Tuesday last week, I believe. Or was it the week before? Were we here the week before? I don't know. Well, anyways, to get rid of a square root of 2 on the bottom, we have to multiply by what? Does everyone remember? To get rid of a square root, you multiply by the same square root. Right? Yeah. Thank you so much. Can you take that out? Appreciate you. Can you leave it out, though? Thank you. Now, to get rid of a square root on the bottom, we multiply by the same square root, right? So, check it out. Times square root of 2 on the bottom and the top. We definitely did this before. Last Tuesday, right? Or was that the week before that? But nonetheless, you can't have a square root on the bottom. You multiply by the same square root on the bottom and the top. Now, what is 5 times the square root of 2? 5 square root of 2. They don't combine because one's a whole number, one's a square root. And then on the bottom, square root of 2 times square root of 2. What's square root of 2 times square root of 2? What do you think? Someone said it, but square root of 2 times square root of 2 is just the number 2. It gets rid of the square root sign. Because square root of 2 times square root of 2 is square root of 4, and hopefully you know the square root of 4 is just regular 2. Now, that ugly fraction is done. We rationalize the denominator. Okay, so now we have this. X equals 5 square root of 2 over 2. So now on our grid, when it says x by itself, okay, now I can fill in this fraction. It doesn't look pretty, but that's the answer. And it's kind of too small there, but oh my gosh. Okay. Hopefully you can see that. Now, again, we're going to forego Pythagorean Theorem. Number 4, as much as I want to do a fun word problem, I want to show you one more example. So on number 4, real quick, scratch that out, draw that picture. I'll give you a second. Scratch out number 4, draw that picture. You with me? Okay, getting this down. We're redrawing number 4. We're going to scratch out the problem and then... So here's another one you might see. Now, this is a right triangle. And if it's isosceles, what do I put here and here? 45, 45. So since it's 45, 45, 90, let's do our little grid. And then my rules are x, x, x square root of 2. Now, 3 square root of 2 is across from what angle? 90. Sometimes it's across from the leg, but this time it's across from 90. So across from 90, I'm going to put it on the bottom, right? 90. Now, think about this. Everyone looking, this is the last example, so just give me your attention for a couple more seconds and we'll be done. If x square root of 2 equals 3 square root of 2, what is x? 3. Okay, real quick. If I was going to solve for x, I would divide by the square root of 2, and it would cancel out. Divide by the square root of 2, and hey, that would also cancel out. X equals 3. So x equals 3. So if your hypotenuse has a square root of 2 on it, you know what the legs are. That number out front. Okay. Now, that's it for the notes. What I want you to do is this assignment. Now, tomorrow we have to move on to 30, 60, 90, a different type of triangle. So this, I want it to be short and sweet. And I'm going to be honest with you. Y'all like honesty. I don't like this. Okay? Here's why. This only works for a special type of triangle. If you don't have a 45, 45, 90, this won't work, right? After this, I have to teach you 30, 60, 90. That works only for 30, 60, 90 triangle. But then after that, I have to teach you trig. And though you may not like it at first, you might understand it, and that works for any type of right triangle. So in the end, you could just be using trig to do these. I don't want to, I have to. So I have to teach you this. I'm just letting you know. If you don't like it, I'm with you, but we got to do what we got to do. Okay? Trig is fun. And it also has some fun songs. Y'all will love them. Like getting triggy with it. Stay tuned. All right. So on your assignment, okay, I'm going to tell you which ones from the notes will help you do which ones on the assignment. Ready? So stay awake because you got to finish this today. So check it out. On your assignment, example 1 is like example 1, example 2, example 3, example 7. 1 second. We're not done yet. Example 4 is like number 3 and number 6. And then example, what was it? Example 3 is like 5, and example 3 is like 8. Okay, so again, these numbers are what examples from the notes are like the ones on the assignment. So again, if you're stuck, look at those notes examples. You need to try to finish this. Ideally, knock it out today because we're going to be moving at a pace where we have to not get behind. So let's work on that today.